In this video, we are going to talk about something called prime factorization. Another name for it is something called factor trees. And this technique is going to show you how to break any number down into its prime number factors. And then we're also going to be using this method to find something called the greatest common factor and the least common multiple. So first we want to talk again about what a prime number is. So a prime number is simply a number that can only have factors of 1 and itself. So just as an example, the number 7 would be prime. Because when you start multiplying numbers together to get 7, the only numbers that you can multiply together to get 7 would be 1 and 7. Now, another prime number would be 3. If you tried to multiply two numbers to get 3, the only two numbers you can multiply together would be 3 and 1. So these are some basic examples of prime numbers. So prime factorization is breaking a composite number down into all of its prime factors. So composite numbers are any number where you can have more than one factor to multiply together to get the number. So let's just go ahead and get started with an example to show you what I mean. So we're going to start with 25. This is a composite number. The reason it is composite is not only can you multiply 25 times 1 to get 25, but you can also multiply 5 times 5 to get 25. So when you do the prime factorization or the factor tree for 25, you start by breaking it down into 5 times 5. Then we look at these two factors and we say, can we take 5 and break it down any further? Well, no, we can't because, again, 5 is a prime number. So what we do is we circle when we come to a prime number. So 25 is somewhat unique in the fact that it is a composite number because it can be multiplied by 25 and 1, but it can also be multiplied 5 times 5 to get 25. But the prime factorization of 25 is 5 times 5. So let me go ahead and show you another example that kind of gives you a little bit more of an idea of what we're talking about. So let's talk about the number 24. So 24 is a composite number. You can multiply more than one factor together to get the number 24. So I'm going to go ahead and start breaking this number down to get to its prime factorization. So the first thing that comes to mind for me is 6 times 4 is 24. So I'm going to write 6 and I'm going to write 4. Now, when I look at 6 and 4, I think to myself, okay, well, I can break those down even further. So I'm going to start with 6 and I'm going to say, what times what would give me 6? Well, 3 times 2 would give me 6. So let's come over here to 4 and say, well, can I break 4 down? Well, I can. What times what would give me 4? Well, 2 times 2 would give me 4. So now when I look at the bottom of my tree here, I've got a 3, 2, 2, and 2. And I think to myself, can any of these numbers be broken down into more factors? And the answer is no, because with 3, the only thing you can multiply by 3 to get 3 is 1. With 2, the only thing you can multiply 2 by to get 2 is 1. So these are prime numbers, and we have done our prime factorization of 24. Circle all of your prime numbers, 3, 2, 2, and 2. So the prime factorization of 24, we would write 24, put a colon, and start listing all of our prime factors. So we have 3 times 2 times 2 times 2. So if you took all of these prime numbers, 3 times 2 times 2 times 2, and multiplied them together, you would get 24. Now let's say that when I was doing the prime factorization of 24, oops, sorry about that, I thought to myself, well, 12 times 2 is 24. So you break 24 into 12 and 2. That is completely fine. You will notice, though, right away you have a prime number of 2. So you would want to go ahead and circle that because you can't break 2 any further. But 12 we can continue to break down. So I'm going to think to myself, with 12, what times what would give me 12? Some of you might think 6 times 2. Some of you might think 4 times 3, whatever works for you. So here's 4 and here is 3. Again, I see another prime number. It is 3, so I'm going to go ahead and circle that because I know I can't break 3 down any further. But 4, I can still keep going. So I'm going to ask myself, with 4, what times what gives me 4? 2 times 2. Well, I can't break 2 down any further because the only factors of 2 are 1 and 2. So here's a prime factor and here's a prime factor. And if you notice, they are all the same prime factors as when we broke 24 down using 6 and 4. So whatever way you go about breaking it down into the prime numbers, you are going to get the same result each time. So let's go ahead and try another one for practice together. If we do the number 64, 64 is a composite number. There are more than just itself and 1 that we can multiply together to get 64. So right off the top of my head, I know that 8 times 8 is 64. So I'm going to break it into 8 and 8. Now, 8 can be broken down even further into 4 times 2. Same thing over here, 4 times 2. So I see 2, and I know that 2 is a prime number. So I'm going to go ahead and circle that to know, okay, 2, I can't go any further here. But 4 is still a composite number, so we want to continue to break it down. So 4 breaks down into 2 times 2, and this 4 breaks down into 2 times 2. And now I have 2's, which I know are all composites, or I'm sorry, prime. So I'm going to circle those, and I can't go any further. So the prime factorization of 64 would be 2 times 2 times 2 times 2 times 2 times 2. So if you multiplied 2 together 6 times, you will get 64. We can also write this as 2 to the 6th power, showing that I multiplied 2 6 times in a row. I want you to go ahead and try this one on your own and then continue to play the video to see if you got the correct answer. Let's try 36. Okay, let's see how you did. So for me, 36, I would break it down into 6 times 6 because it's just one that I know and I remember. But I know 6 can be broken down even further into 3 and 2, which means this 6 can be broken down even further into 3 and 2. I know that 3 and 2 are both prime numbers, so I'm going to go ahead and circle these because I can't break them down any further. So the prime factorization of 36 would be 3 times 3 times 2 times 2. But let's say you broke it down. Let's go ahead and do it over here. Let's say we thought, well, I also know that 12 times 3 is 36. Automatically off the bat, we should know 3 is a prime number. So let's go ahead and circle that because we know we can't break that down any further. But 12 can continue to be broken down. You could have broken it down into 6 times 2 or 4 times 3. It's up to you. I'm going to go ahead and do 6 times 2. Well, there's another prime factor, right? We know 2 is prime, so I'm going to go ahead and circle 2. But 6 can continue to be broken down, so I'm going to take 6 and break it down into 3 and 2. Those are both prime numbers, so I'm going to go ahead and circle them. And you can see that even if I broke it down this way, I still have 3 times 3 times 2 times 2. So the prime factorization of 36 is 3 times 3 times 2 times 2. Let's go ahead and try one more. Try this on your own, type in your answer, and then we'll go ahead and go over it together. 16. Okay, with 16, I'm going to go ahead and break this down into 8 and 2. Some of you might have broke it down into 4 times 4. Either way is fine. But I do know that if I did this, I do see a 2. 2 is prime. I'm circling it. I am done with it. But I can continue to break down 8. Well, 8 can break down into 4 and 2. 2 is done. That is a prime number. I'm going to go ahead and circle. But 4 can continue to be broken down into 2 times 2. 2 is prime. We circle it, and we're done. So 16, its prime factorization would be 2 times 2 times 2 times 2, which is the same thing as 2 to the 4th power because we multiplied 2 4 times. This introduction into what we like to call factor trees or prime factorization is really going to help when we are learning about the greatest common factor and the least common multiple, or what we like to call the GCF and the LCM, when we are learning about these this week in class.